Hi guys, this is lesson 3 of our algebra unit, solving equations because we've actually been working on algebra expressions, simplifying, but now this is day 3 of solving equations. And what we have here is, it says find the value of one unit in each case. We are actually, in addition to this, going to write an equation and solve it, and then we're going to do a check down here. Okay, so here we have an x, and a smaller x. So we have an x, and an x that appears to be reduced by an amount. What's the amount? That dotted line means that this x is actually x less 5. It's a smaller x, and we can highlight that to show that this x is in fact not a complete x, okay? So remember, the goal in algebra is for us to understand what is the value of one of the x's. Okay, so in order to do that, we need 3 complete x values, and one of these is less 5, so what do? We're going to add a 5 back in. Okay, so if we add a 5 back in here with the x's, we have to add it into the complete equation. So now we have a total of, okay, this whole x now, this partial x has been increased to a whole x because we added the 5 in. Now we have 3 x's is equal to 21, and I know that all of you, of course, know how many 3's are in 21. So we have 3 x's is 21. And then now let's write out the equation. So we have x and x, which why don't we say combine those as 2x, plus an x less a 5, that smaller rectangle, all equals 16. So again, we have a situation here because one of the x's, and remember the coefficient on this x is actually 1. So we have 3 x's, but one of the x's is smaller by 5. So what do we need to do? We're going to add a 5 back in to give us a complete x. And of course, in algebra, we want to keep everything weighted the same. If we add 5 here, we have to add 5 on the other side. So now we added a 5 back in, which means that becomes 3 complete x's. 2x plus 1x is 3 complete x's. Has a value now of 21. So 3 complete x's is 21. So we want to break those x's apart like they are here. That's dividing, breaking into equal groups is dividing, right? So 3 divided by 3 is 1x. Ta-da, 1x. And 21 broken into 3 parts is 7. So now let's check it. Let's check to see if 7 plus 7, and that's what? Yep, 14. And then 7 minus 5, which is what? 7 minus 5 is 2. Do these numbers, rational numbers, total 16. 7 and 7 is 14. 14 plus 2 is 16. Wow, it works. Okay, let's go to the next one. I'm going to erase this. Hopefully you have it written down. If you don't, just hit pause, take your notes, and then press play again. I'm going to erase this, okay? The next problem is B. And I know I keep using the variable x. We can use, I don't know, C. C, one C, another C, another C, and another C. This last C is a smaller c. How much smaller? It's smaller by 1. So this is going to be C less 1 because it's a smaller c. Let's highlight that in pink. Maybe that goes with my burgundy. Okay, let's see. Smaller c. All right, that's a problem, right? Why? Because we want to know 1, 2, 3, 4, we want to have 5 C's that we divide into 1 C. Like, what's the value of 1 C? And we have a total of 11. So, what do we need to do? We need to add 1 back in. And if we add 1 back in here, we add 1 back in here. At the end for our total of 12. All right, and now we have complete C's. 1, 2, 3, 4, 5. C's is 12. 5 kids, $12. You are at, I don't know, 7-Eleven. And it's 5 friends, $12. How much does each friend have to spend? Let's write an equation for that. C plus 1, 2, 3C. And we could have combined those, obviously. Plus that smaller C, which is a C minus 1. That has a total of 11. So again, you know, we have the C and there's a problem. We want to have all these C's to divide up. So let's add our 1 back in to our complete equation. And now we were less 1, we added it in. Our total is 12. And now let's count our C's, which is simplifying, combining like terms. C plus 3C is 4C, plus C is 5, C's is 12. Okay, so now let's divide our 5 C's into 1. So divide them by 5. We're going to divide our 12 by 5. So C is 12/5. And the question I have for you, is 12/5 a number you're comfortable with? Well, we can leave it improper because we know that when we go to check the equation, it's super easy to check an improper fraction. So let's do that first. I know you may not be comfortable with the answer, but let's just keep it and see. Check. And I'm going to move the screen up. Maybe I'll just create a white space so that we have something to work on. And you should have a piece of paper because you're prepared. All right. So let's cover this up briefly. And we can move the word check up. Okay. So now let's do our C's. C is C, 3C, 4C, minus 1. It should be 5. Pardon me. Really and truly, I should write it out as it originally was so that I don't make a mistake like I just made. Because in algebra, as well as in all math, mistakes are, Kenny is coughing. You okay?
Yeah.
Okay. Mistakes are super easy to make. So let's check. What is the value of 1C? Well, truly, we should add these up. 3C, that's 1C, 3C. 5 C's minus 1 equals 11. Now, checking means we take that weird answer we had, that improper fraction, and we plug it in for our C, 12/5, and I'm already feeling really great about the idea that we got this fraction because fractions are our friends. They're super easy to work with. So let's reduce our 5. Divide 5 by 5 and 5 by 5. You get 1. 12 times 1 is 12. And look, 12 minus 1. Does that equal 11? Well, let's do it over here. 11 equals 11. So that very strange answer of C is 5. C is 12 over 5 is actually the answer. Okay, so press pause. Fill that out if you need to. I'm going to erase this, and then we're going to move on to the next one here. All right. Okay. C. Let's do N. N, 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 and another N that's smaller. We have a smaller N. So that's not actually N, is it? That's wrong. That's going to be N less ... N less 4. Okay. So, what do we need? And all of that equals 1. So, let's write our equation out. N plus 2N plus N minus 4 equals 1. Wow. Pretty small, right? The total. We're probably going to have a answer that's a fraction. Okay, so we have a n that's smaller, so we need to do what? Got to make it larger so we can separate them all. So let's add the 4 back in. If we add the 4 in here, that restores our n. So that's what we want to do. Take our -4, add it back in, so that we have enough n's to separate. That was weird. Okay. All right. So our total went up. It's 5. Oh, wait a minute, guys. I'm going to move that up there. Okay. 5. And then we have 1n, 2n, that's 3n, plus n is 5n's is equal to 5. 5 students, $5. I'm being generous. How much does each student get? Ding, ding. $1 bill. All right. So n is equal to 1. Let's check it. 1, circle, 1, circle, 1, circle. 1 minus 4. What's 1 minus 4? -3. Something's wrong here. -3 plus 3 is 0, not 1. Something's wrong. Let's go back and check it. That happens in math. So let's go back and check. All right. I didn't have a script, so we made an error. N, 2n, and n minus 4. So that's 1, 2n's, 3n's, 1n, 2, 3, 4n. No wonder. This should be 4n. I'm sorry. 4n's is equal to 5. So n is going to be equal to 5/4. Another interesting answer that we're going to check. N is equal to 5/4. All right. Oops, I'll move that down. I guess I may have to re-record this, but I'm hoping not. All right, so let's check it. And let's write check. N plus 2n, that's 3n, plus n, that's 4n. Minus 4 equals 1. All right, let's move it down some more so we can get a great look at this. Okay, and then we have 4 times 5/4 minus 4, does that equal 1? Can't be afraid of fractions. All right, and sometimes we make errors just like I just made, and you just go back and correct it. And how did I know? Because I checked it. So now 4/1, and we know that we can divide our numerator here, 5/4, and get 1. We can divide our denominator 5/4, get 1. 5 times 1 is 5. I'm feeling good. Minus 4 equals 1. Well, we have to see, does 5 minus 4 equal 1? Yay! 1 is equal to 1. It checks. Phew, that was a lot of work. All right, so anyway, you're going to do 2A, B, and C. But in the meantime and in between time, let's go back to the problem. Oh, and then I also want you to do this problem. Number 2 from the warm-up yesterday, or whatever, the previous lesson or whatever. -3 plus 8n, plus 8n is equal to -5. So, again, here we have a problem that is reduced by 3. What do we want to do? We want to add the 3 back in. So go ahead, and if we add the 3 back in here, we add the 3 back in here. So I trust you immensely that you know how to do this correctly. Over and out.